Again, this is CT-1. It is the cybersecurity research and development scope area. NE has a fairly unique cybersecurity program from what I've seen of other types of programs. So I am going to go through a little bit of what we are and are not trying to do. Again, the kinds of scopes that we funded before and what we are and are not looking for in this area. Our cybersecurity R&D program is focused on applying cost-effective cybersecure digital technologies and communications for the current fleet and for next-generation power plants. There's kind of a mouthful in that, but the cost-effective element is a really key part of it. We are not fundamentally a security type of organization or program. What the Office of Nuclear Energy's R&D program is doing is looking at ways to take the cybersecurity that is already being done in nuclear power plants. It's already regulated, it already exists. Looking at ways that we can improve our understanding of risk, use risk-based processes for managing and applying controls, and also look to the next generation of reactors and technologies and advanced concepts and say, are there aspects of these advanced technologies that would be useful to nuclear power to improve their economics, to improve their performance, et cetera, but for either a real or perceived cybersecurity concern, or maybe cyber is just one part of why it's not in use yet. I can think of a lot of advanced digital technologies, artificial intelligence, wireless control, a number of things that could gain traction in nuclear operations or nuclear plant design. But there are cybersecurity aspects of making those things a reality. We focus on designing secure architectures, looking at risk management methods and the nuclear supply chain, and then we have a modeling and simulation platform to test out some of these ideas. These are the main elements of the program, whether accomplished through the national laboratories, which is primarily Sandia and Idaho National Laboratories leading the work that we have ongoing in this area, and also the various university and small business scopes. We try to focus in these general areas, although it's not necessary to self-identify as attaching to any one of these areas. Obviously, a lot of different cybersecurity concepts and technologies rightfully cross over a number of these areas, or they're holistic. So these are the general things we look at to give ourselves a benchmark, but we don't require that applications figure out how they fit into one of these areas or identify themselves this way. This is just for information. This is where the cybersecurity program fits in the Office of Nuclear Energy. And I know the different programs that are here sometimes fluctuate and there's different names and priorities, but the general idea is that we have a great deal of work going on to focus on current fleet reactors and next generation future fleet reactors. Cross-cutting technology programs, of which cybersecurity is just one, do work that supports both areas. The early years of this program, we were really focused on helping the existing fleet as the NRC was rolling out regulatory approaches for cybersecurity, helping to understand the tools and techniques and any barriers to implementation. And we spent a lot of time in that realm. We still are doing some work there supporting various digital modernization campaigns and so forth, and understanding how cybersecurity considerations, if any, affect different integrated and hybrid energy systems ideas that are going on. So there is some of that work, but we've recently shifted gears and we're really trying to put more of our emphasis on cybersecurity by design in new reactors, cybersecurity architectures, and again, understanding how advanced technologies could really help enable some of the most promising features of the next generation fleet. The coal interest area will look very similar to last year's because it's the same kind of information that we are always looking for. It's again very broad based, and we're open to a whole array of ideas. So we're less likely to narrow it down by technologies, though there are a couple of things we've previously funded that we are less interested in. But for the most part, to be really clear, the cybersecurity that we talk about for the nuclear power plant we are limiting ourselves to things that are not being done by other types of programs. So that's the sort of thing you would see, say, Department of Homeland Security doing for industrial control systems generally and so forth. We make sure that we're not duplicating that kind of work. We're looking at either the cybersecurity of technologies that are maybe most important to nuclear plants, so they're not a priority for other research programs, or figuring out barriers and obstacles to why other advances might not yet be incorporated into nuclear power plants. So we're looking to enable secure communications for these reactors. We're looking at the safety and security related control systems, so not other peripheral information technologies, things basically plant internals and NRC licensed types of reactor areas. And so some of these things could also look at advanced reactor control concepts, remote and autonomous operations, different kinds of monitoring systems, secure communications. Those are some of the ideas, but it's not limited to that. As long as it focuses on the reactor control systems and reactor security systems, again, things that are on the NRC regulated side of it. So we're not looking at grid cybersecurity or just general SCADA type things you would see in other industrial control systems. It has to be about nuclear power plants. Other things that, primarily because we've funded them before, and I think we've gotten as far as we can in making use of them, is general purpose understandings of attack scenarios and intrusion detection tools like you would see just, again, that are sort of general purpose industrial control systems things. We've done some work in the past looking at high-level reactor physics models and comparing those to off-normal operations as a detection tool. So those aren't completely ruled out, but there would have to be something new or different than what we have already funded in the past and what's already been done. So the key here is really to stay away from proposing, let's start at the beginning kind of work, get a good understanding of what exists in the nuclear industry, what other research has already been ongoing, and try to bring new advances into the picture here. So that's really what this is trying to get at. Some of the past things we have funded, this is over the last few years, so we've moved over time. You'll see there are some method developments and that we used university research reactors early on to help understand and demonstrate some concepts. We have done some threat analysis. We've done a number of things. Some of the more recent ones are like this one on information trustworthiness and integrity algorithms. We have done some simulations and attack detections. So one of the more recent ones that I think was just from this last year is the one that's about quantum key distribution. So we're really trying to stay in the space of, and again, I'm not saying that these topics couldn't be revisited if there are more advances to be made in those areas, but the types of things we like to award are really having universities do the kind of research they do best. So as an example, coming in with an idea for how to develop a monitoring tool for cyber detection would probably be less likely because there are a number of that's a very commercial type of application where there are tools in the marketplace already. So unless there was something unique that the nuclear industry needs that the commercial market isn't bringing, where there's really research involved in it, that's what we're looking to, is what does the academic community bring to this subject that the commercial marketplace is not yet? And those generally make the most compelling application. That's all I brought with the charts. If there are any questions.
Okay, thank you, Rebecca. First question, can you point out the differences between cybersecurity of light water reactors and advanced reactors?
To me, the differences aren't necessarily in the nature of the reactors so much as when I refer to the things you did with the existing fleet, you have plants that were already designed and built well before modern digital control systems and cybersecurity considerations were there. So you're trying to bring cybersecurity into the environment after the fact and into an existing operational environment. And there's already been a great deal of success in that area. The work that we've continued to do, again, we're not a security program, so we're not auditing and improving and looking for all the holes so much as trying to figure out how to make it more efficient, more cost effective, more integrated with the other aspects of reactor operations. So that's a lot of what we've done there, except when there are digital control systems upgrades. Helping to work with cybersecurity by design is also a factor. When you look to advanced reactors, where a lot of things are still open and on the drawing board, obviously, the farther out a reactor concept is, the more room there is for this. How do you do things like this, design cyber architectures from the beginning so that they are robust? Can you remove dependencies altogether from various cybersecurity aspects? So looking at the architectures, the way they're designed, the way the controls might be put in place, but also looking at whether there are advanced parts, components, methods. It's a whole range of things. So it's not just architectures, but looking at if you have advanced concepts where they get their best value by being, I'm just being hypothetical, so this isn't a narrowing down example, but if you have a microreactor where the business case that really makes it shine requires that you remote control it, that's really inconsistent with how nuclear reactor cybersecurity is done now. So understanding whether there are technology gaps or if it's mostly regulatory, but I think there are things that can be done to really advance the specific use cases for the nuclear industry for the advanced concepts that are out there.
Okay, thank you, Rebecca. The next question. I wonder what kind of communications are considered here. Is it at the level of communication of networks and protocols, or is it at the level of physical layer communications?
Any and all of the above, if it is specific to the needs of a nuclear power plant. Was that a sufficient answer, or was that something? I want to make sure I answered it.
We'll let the person who asked it to put a note in if they need more clarification. So at this time, we don't have any more questions for this Workscope. I do have one back on RC6. If we could
Sure.
just jump back there for just a second. And someone asks, what kinds of online sensors might be of interest for RC6?
I can't specifically identify. We haven't narrowed the scope to that level of fidelity. Again, it's up to the applicant to identify some kind of a use case or scenario that advances the value proposition for SMR specifically, and they can bring any technology to the table that does that.
Okay, great. That looks like that's all the questions we have for these sessions right here.